In this question here, we have an infinite spiral. And basically, you get to see that it kind of goes around, represented by the solid line. You've got a right angle triangle at each segment, and all triangles are similar. And because they're all similar, you can get the length of each particular segment as it continues. And you can probably see that at the start here, this is length 12, which was on the side length of one of the triangles. But as it gets to the next triangle, it becomes the hypotenuse. And then so the side lengths will become smaller because they're similar triangles. And then this side length becomes the hypotenuse, so it becomes smaller again. And so this side length, both in the diagram and just mathematically, you can see will become shorter. And then this continues. They didn't draw it, they just drew the first four, but the idea is, in a very rough way, this will just continue to get shorter and shorter and shorter, and so on. And you'll get a spiral that is infinite, that will go forever. So you want to find the length of the side marked x. We'll do that algebraically. And then you want to now find the length of the entire spiral, which is infinite, which really means that you have a series here that you want to add up. And if you want to add up an infinite series based on the content you know, then you might think about what type of series you might expect that to be. But let's just now focus purely on the diagram. Or in fact, let's draw our own one. So we don't really need to draw out the entire diagram. We just really need to focus on the parts that are important for us, which is the very first one. This is a right angle triangle with a length of 12 centimeters here and 9 centimeters here, followed by another triangle, which I'll do in a different color. And this is the right angle here. This is x, and this is some unknown value. I'll just label this O, okay, so as a center, and we'll call this ABC. And we are told that triangle ABO is similar to triangle. You can quite clearly see that the letters, of course, you can see this is the hypotenuse, so this will now be the hypotenuse. So ABO will be equivalent to BCO. You probably won't get as many questions on similarity going forward. I mean, they still might pop up, but because of the fact it's more based on geometry, but let's just apply that here. Given you're told they're similar, what that then means is that the ratio of your triangles must be proportional. So in other words, AB, which is this length over here, divided by the equivalent in the next triangle, which is BC, must equal BO divided by its equivalent, which is CO, but it's also equivalent to AO divided by this triangle's equivalent, which is BO. Now, you'll need to consider what you know and don't know. You want to find BC, so you must involve this. That's your x. You must involve this. You know AB, which is great. This is known. That's helpful. And you know BO. Now you don't know CO. Okay. And we want to, this is your unknown. And you need the other side to be known. You don't need all three. You just need to pick a pair. So we're clearly going to use this because it's got an unknown involved. And we're either going to pick BO over CO or we're going to pick A over BO. And the question is, can you work out CO or can you work out AO? Because you need those numbers. And a quick look at this should show you that AO is just the hypotenuse, and you know AB and BO, so you can work out AO. So in other words, we would focus purely on this one and this one. In other words, we'd say AB over BC equals AO over BO. In other words, 9 centimeters over x is equal to, use Pythagoras, 9 squared plus 12 squared. And you should be able to recognize that's going to be a 3, 4, 5 triangle, so it's going to be just 15. all over BO, which is 12. Right? And so that means X does therefore equal 12 times 9 divided by 15. Giving you an answer of 7.2 centimeters. So the answer to part 1 is that X equals 7.2 centimeters using the fact that the triangles are similar. Now, the next part of the question wanted us to find the length of the entire spiral. And I'm just going to draw the next one out just to convince you of a fact before we just apply this indiscriminately. So let's say we now have D, and let's say that's a right angle, and let's call this Y. So basically, this very similar argument would be made, right? So I would now say that triangle BOC is similar to triangle COD. But that, of course, means that the length DC over X must equal, well, OC over BO. But we can actually see what OC is going to be because we can work out OC. Knowing that X is 7.2 now, we now have a ratio, right? We actually know the ratio because this is 9. Remember, this is 9 now. And this is 7.2. We've now worked that out. So what we're basically saying is that the ratio of the big triangle over the small triangle is 9 over 7.2. So if BO was 12, then CO must basically be 12 times 7.2 over 9. That's the kind of the ratio. It's the original length, 12, times 7.2 over 9, giving you 9.6. So in other words, we've now worked out CO is 9.6. And what I'm really going to say here is essentially we expect, given the question and so forth, that because all these are similar, that the ratio is still going to be the same. In other words, the ratio is 7.2 divided by 9, which is 0.8. Okay. And we'll just compare. Your 9.6 is your CO, or your X is 7.2. We can get your Y. We'll just quickly work that out. So your DC is your Y over X equals CO is now known, BO is now known. So DC must equal 7.2 times 9.6 over 12, which of course is 0.8, which is 5.76. So what I'm really getting at here is every time you go down, it gets smaller by 0.8. Your length of your size goes from 12 to 9.6 to 5.76. You've gone from 9 to 7.2 to 5.76, sorry, to 5.76. We actually haven't worked out the next one. But what it would be 9.6 times 0.8, and that would be 7.68. So for us, what we care about is the length of the spiral. And the length of the spiral is literally just really, you're adding this section plus this section plus this section. You're just adding that, and it keeps going. So we just really need to add 9 plus 7.2 plus 5.76 and so on. So really, the length of the infinite spiral is equal to 9 plus 7.2 plus 5.76 plus ... We note that this is, each time it's getting smaller and it's being multiplied by 0.8. That's the ratio. So that means this is a sum of a GP, where A is 9 and your R is 0.8, which is required because for an infinite sum, you need r to be between 1 and -1. And that lets you then use your GP formula, a over 1 minus r, to get 9 over 1 minus 0.8 to give you an answer of 45. And so the length of the infinite spiral will equal 45 centimeters. And that's how you do the question.